This video is all about solving quadratic equations by extracting square roots. Welcome to my math class, Mathematics Made Easy. Click like and subscribe. The objectives for this lesson are: recall the squares of numbers in the various forms of quadratic equations. Identify equations that can be solved by extracting square roots. Solve quadratic equations by applying the following properties. Property 1. If k is greater than 0, then x squared is equal to k has two real solutions or roots. That is, x is equal to positive negative k. Property 2. If k is equal to 0, then x squared equal to k has one real solution or root. That is, x equal to 0. Property 3. If k is less than 0, then x squared is equal to k has no real solution or roots. Recall the standard form of a quadratic equation: ax squared plus bx plus c equal to 0, where a, b, and c are real numbers, and a should not be equal to 0. The various forms of the quadratic equation. We have the first one, which is in standard form, is ax squared plus bx plus c equal to 0. The second is ax squared plus bx equal to 0 when c is equal to 0. And we have ax squared plus c equal to 0 when b is equal to 0, or we can write it as ax squared minus k equal to 0 where c is equal to k, or that would be ax squared is equal to k. The quadratic equation of the form ax squared minus k equal to 0 or ax squared equal to k can be solved by extracting square roots. A solution to this equation is called a root. The solution or roots of a quadratic equation are the value or values of the variable which makes the equation true. How do we extract square roots for x squared minus k equal to 0? To solve this equation, follow the steps. Step 1. Isolate the quadratic term. So we have x squared equal to k. Step 2. Extract the square root of both sides of the equation. So we have here the square root of x squared is equal to the square root of k, which is equal to x is equal to positive negative k. There are two solutions to our quadratic equation, k and negative k. Note, a quadratic equation can have two or only one real solution. In some cases, it can have no real solutions. The square root principle states that if x squared is equal to k and k is greater than or equal to 0, then x is equal to the square root of k, or x is equal to the negative square root of k. The reverse of squaring a number is extracting its root. We have here table of perfect squares and square roots. So we have the column for x squared, the column for k, which is x squared is equal to k, and the square root of k and positive negative x. 1 squared is equal to 1. The square root of 1 is equal to positive negative 1. 2 squared is 4. Square root of 4 is equal to positive negative 2. 3 squared is equal to 9. And the square root of 9 is equal to positive negative 3. So on and so forth until 20, wherein 20 squared is equal to 400, and the square root of 400 is equal to positive negative 20. Let us define square root. A number x is a square root of k if x squared is equal to k. In algebraic form, positive negative square root of k is equal to x if and only if x squared is equal to k. Let us take, for example, 4 squared is equal to 16. If and only if the square root of 16 is equal to positive negative 4. Another example, 11 squared is equal to 121 if and only if the square root of 121 is equal to positive negative 11. In the table of squares and square roots, the number 5 is called the square root of 25 because 5 squared is equal to 25. The square root of 25 may be equal to negative 5 because quantity negative 5 squared is equal to 25. The number 11 is a square root of 121 because 11 squared is equal to 121. The number negative 11 is a square root of 121 because the quantity negative 11 squared is equal to 121. The number 1/3 is a square root of 1/9 because quantity 1/3 squared is equal to 1/9. In square root 121, positive 11 is called its principal root. Let us define principal root. If k is greater than 0, the expression square root of k represents the principal or positive square root of k. The principal square root of 0 is 0, that is, the square root of 0 is equal to 0. In short, the principal root is the positive root of a rational number. Let us solve quadratic equations by extracting square roots using property 1. If k is greater than 0, then x squared is equal to k has two real solutions or roots. X is equal to positive negative square root of k. Example, find the solutions of the equation x squared minus 64 equal to 0 by extracting square roots. X squared minus 64 equal to 0. To solve this, we add the additive inverse of negative 64 to both sides of the equation. And we have x squared is equal to 64. Extracting the square root of both sides, we will have x is equal to positive negative square root of 64. So we have x is equal to positive negative 8. So the roots are x is equal to positive 8 or x is equal to negative 8. Let us check whether the values we had for x, 8 and negative 8, is true for our given equation. So when x is equal to 8, we substitute it into the equation x squared minus 64 equal to 0. So we'll have 8 squared minus 64 equal to 0. That would be equal to 64 minus 64 equal to 0. So 0 is equal to 0. When x is equal to negative 8, the same as in the first, we are going to substitute negative 8 into x. So quantity negative 8 squared minus 64 equal to 0. So that would be 64 minus 64 equal to 0, and 0 is equal to 0. Check. Our values for x are correct, or will make our equation true. Property 2. If k equal to 0, then x squared is equal to k has one real solution or root, which is x equal to 0. So our example, solve the equation m squared equal to 0. So m squared equal to 0, we extract the square root of both sides. So the square root of m squared is equal to 0. So 0 squared is equal to 0. So 0 is equal to 0. Property 3. If k is less than 0, then x squared equal to k has no real solutions or roots. Example, find the roots of the equation x squared plus 9 equal to 0. X squared plus 9 equal to 0. Using addition property of equality, we add the additive inverse of positive 9 to both sides of the equation, which is negative 9. So we have x squared is equal to negative 9. So our k is less than 0, or it is equal to negative 9. Our answer would be the equation x squared plus 9 equal to 0 has no real solutions or roots. Thank you for watching my math class, Mathematics Made Easy. Don't forget to click like and subscribe. Thank you, and see you next video.